Today we are going to see a topic related to the previous video, electric field lines. Okay, or you can say the other name of this is uh, electric. Just a second. Electric lines of force. Okay. What this actually is? It is you can define this term as basically these are imaginary smooth curves. Okay, imaginary smooth curves in an electric field. Okay, in an electric field along which a isolated positive charge moves. Okay, along which an isolated positive charge moves. It will be more clear to you later in this video when I'll draw electric field lines due to different charges. That is for isolated positive charge, for isolated negative charge, equal and like charges, equal and opposite charge. Okay. Just basic term, basic definition of electric field lines. That is, these are the imaginary smooth curves in an electric field along which an isolated positive charge moves. Okay. Now, if you want to know the direction of force, okay, on a positive charge in an electric field, then uh, the tangent, okay, the tangent drawn to any point in electric field, okay, drawn to any point in electric field lines will give what? Will give direction of force acting. Okay. Okay. Uh, then if you want to draw electric field lines for different cases, okay. First we are considering an isolated positive charge. Okay. Isolated positive charge. Okay. Now we want to draw electric field lines due to this. Suppose this is isolated positive charge. Then the electric field lines will be somewhat like this, emerging from this charge. Okay, like this means they will be originating from this positive charge. These will be the electric field lines due to isolated positive charge. Okay, they will be emerging. Always remember that due to positive charge, the electric field lines will be emerging from them, and due to isolated negative charge, the second case, isolated negative charge. Uh, these are the basic cases I'll discuss when there are more than one charges. There will not there if there will not be isolated, then what happens? Okay, I'll discuss it later. Then due to isolated negative charge, suppose this is isolated negative charge. Okay, can you guess the direction of electric field lines? It will be somewhat like this. They will be converging towards the okay negative charge. Okay, somewhat like this. The direction will be like this due to isolated negative. Okay, now the third case, when equal and like charges are placed. Okay, equal and like charges are placed. Okay, like this somewhat. Suppose this is a positive charge q and this is negative charge. Okay, now we want to draw electric field lines due to these. I have told you that for a positive charge what will the electric field line directions will what will the direction of electric field line? They will be emerging from these. Okay, like this. So the direction will be somewhat like this. Okay, like this. Oh, just I made it wrong. The direction will be like, okay, they will be uh, emerging. Okay, now for uh, I have actually made equal and like charges, so we should make it the other one as positive as well. Okay, this one we are doing this case for equal and positive charge. So for this charge as well, what will be the direction? It will be somewhat like this. They will be emerging from, okay, like this. Now the fourth case, that we want to draw electric field lines due to unlike charges. Okay, equal and unlike. Suppose this is a positive charge Q and this is a negative charge, right? So how electric field lines would have been? They will emerge from this. Okay, like this. Okay, they will emerge from positive charge. Okay, like this. But they are going to converge towards the negative charge. Okay, means their at negative charge lines will be somewhat converging, like this. Direction will be originating from positive charge and just a second. And remember that two field lines cannot intersect each other. Okay, this is also quite why there is reason for that. That if suppose two field lines intersect at this point, okay, then what will be the direction of force here? This there. Uh, Here this field line indicates that force is there, and this field line indicates that force is in this direction. So it is not possible. Okay, that is why two field lines cannot intersect each other. Okay, and there will be a neutral point. Okay, neutral points means where uh, you can say where forces are equal. Okay, means for due to this positive charge, suppose a positive charge is kept here. Okay, let's say. Okay, then due to this positive charge, what will the force direction of force on this charge? It will be in this direction, and due to this, okay, due to negative charge, okay, what will the direction of force? It will be in this direction. Okay, means the direction of force will be in this direction. Okay, because they are unlike charge. So this will be the neutral point. Okay, and so these were four basic cases. Okay, how you can draw electric field lines due to isolated positive charge, isolated negative charge, two equal and like charges, and two equal and unlike charges. Okay, you can also draw. Suppose they are not equal. Okay, then what happens? This neutral point just shift towards the this side or this side. Okay, depending on the magnitude of charge. Okay, or depending on the uh, magnitude of charge, the distance between a neutral point and other two charges will shift. Okay, so these were the basics. One more thing I would not discuss, I'll just tell you that properties of electric field lines. Okay, basic properties of electric field lines. The first one you should note it, that electric field lines start from positive charge and ends at negative charge. Okay, it starts from positive charge and ends at negative charge. You have seen already this. Okay, then a tangent at any point gives the direction of force acting on positive charge. I have already told you in the start of this video. Okay, that tangent at any point will give direction of force. Okay, right. The third point that you should note, the two field lines cannot intersect each other. Okay, The fourth point, electrostatic field lines do not form closed loop. You just need to remember this, okay? They don't form closed loop, okay? Like in this case, they don't form closed loop, like originating from here and coming here, like this, okay? They don't form closed loop, okay? The fifth point, that electric field lines do not pass through a conductor, okay? Suppose this is a conductor, okay? And electric field lines are coming, okay, like this. Then they will not pass through this conductor, okay? Here there will not be electric field, okay? Here electric field intensity will be zero inside a conductor, okay? And electric field lines always falls perpendicular to a metallic conductor, means here the angle will be 90 degree, okay? They always fall perpendicular to a metallic conductor, okay? And this is also one property. And the last property, which is quite important, that relative closeness of lines of forces in different region gives relative strength. For example, if you say like this, electric field lines are like this, okay? Suppose this is point A and this is point B, okay? Suppose the case is like this, okay? Now what happens here, you can see at point B they are more close, okay? So electric field intensity at point B will be what? It will be more than at electric field at A. Means the how closeness increases, okay, then electric field intensity also get affected by closeness of electric field lines. Where the electric field lines are more closer towards each other, there electric field intensity will be more. Okay. So these were some basic points about the electric field lines.